I thought I'd do another video about what I've been doing with the Raspberry Pis on the boat. I've added another one now. I've got a Raspberry Pi 3 and a Pi 4 with 4 gigabytes of RAM. And I'm using the Raspberry Pi 4 as my media server, as well as running Node-RED so that it can run my diesel heater, and then I've got Grafana and InfluxDB linked into it. So it's pretty working pretty good so far. One of the things, I have two of the knockoff Webasto diesel heaters, and they use radio signal for RF signal for their remote. So I've pulled off on one of the pins. I think it's GPIO 17. You can use it to transmit radio signals. So I basically have it, I can show you on the Node-RED dashboard. I've made up a thermostat, and you can control on off, temperature up down, smart thermostat, and then it also incorporates in with Node-RED to calculate how much fuel was burned during the run, how often it comes on, just tracking general usage of the heater. And then it outputs all of that to a Grafana dashboard. Now these are kind of rough right now. I'm only using the 2-gallon fuel tanks for each heater. This is all dummy data in here right now. It's not time to get the systems going. But as you can see here, it tracks the temperature, and then I have it set so that it's basically, let's see if I can, it basically is a staircase line for the system on and off, so that you can distinguish. So basically, that global variable tells Grafana 0 or 50, which tells the system, you see that it went up to 50 here. And we can, with Grafana, you can use all kinds of time frames. Let's go out 5 minutes and you can see what the goal is with this chart. So what we'll do is we'll go back in, and we will, I've got one Node-RED tab for each Raspberry Pi. We'll go back in and set it to 0 now, so 0 being system off, 50 being system on. And it's just for those numbers mean nothing other than that it's a visual representation of system on or off. So you can see during this time, temperature was 70 degrees, system was off. Realistically, the temperature would have came down, would have called for heat, system would have come on, ran for however long, and in this case it ran for almost a minute, and then system was off. It would have displayed over in the debug screen, it would have said system was on for a minute and burned approximately whatever gallons of fuel. And then this would have, for that runtime, wouldn't have really made a difference, but the gauge would be dropping down as each fuel usage adds up between refills. And then I've got, this is my favorite addition. I added an ultrasonic sensor for the Raspberry Pi on my forward Raspberry Pi, and it's mounted into the top of my tank, into the service plate, and it just shoots down at the top of the water, reflects off, and measures distance. And this is a running graph of my water level, and this is just the water level bouncing from being waked or something like that. But and then how much I have in remaining water. Now the sensor measures in centimeters, but so you have to convert it. It measures the water every 2 minutes, or it measures the distance every 2 minutes. And then it brings it out here, and I use a range node to change it from centimeters to gallons. So I know that if the water level is about an inch from the sensor, then it's full, which would be 2.54 centimeters. And to the bottom of my tank is 50.8 centimeters. So this is empty, this is full, and it changes over to 0 to 200, so it gives me a good range. The tank isn't perfectly rectangular, so there's some variation in there, but it's pretty close. But it brings it over into gallons, sends it to my database, which feeds Grafana. And then it also, I have it set so that if the water level drops below 25 gallons, then it sends me a notification fresh water is down to 25 gallons. I have it set to only send one every 6 hours, and it sends that to me via push bullet to my phone, to my computer, to wherever. So let's go through each tab. So then we have the forward water tank, the forward diesel heater. So basically these nodes drive the dashboard. So system off, system on. That's system off, system on. And then, so when you push the button, it starts this flow. It only lets it go through if it's a different command than the last it saw. That way it's not constantly saying off, off, off. So it goes through, this sends the radio signal. The shell script is on the Raspberry Pi, sends a radio signal. I also have it so that it sends a message on the debug. When smart thermostat is on, then it also it goes through and maintains the temperature on its own. This is what's used to calculate how long it was running and how much fuel it burned. And then these are just what's used to calculate the set point temperature and to tell it what to do when you push temperature up or temperature down. But that's what tells it here. Right now I've got it bypassing the temperature sensor just because I wanted to test it, and it's still 95 degrees here today. But basically what it is I have a temperature sensor that's good. 2 temperature sensors that would measure temperature every, let's call it, 1 minute. So I measure the temperature once a minute. It would this is going to repeat every minute. It's going to measure the temperature. Then this would take the temperature, and there's probably a cleaner way to do it, but I haven't done that yet. But it would take those 2 temperatures, or those 2 readings. It would average them out. So say, this is not how it would be done, but reading 1 plus reading 2 divided by 2, it's going to give me an average. That's going to do the set what the inside temperature is, so what this temperature, the current temperature is. Because I've got one thermostat in one cabin and one thermostat in another cabin, so I want it to be the set point to be an average of the 2. That way one doesn't get overly hot and one doesn't get too cold. And that's what drives the diesel heater to come on and off. I just updated my node red, so I've got to go through and tweak this to get the colors right and everything. This is the database node that just kind of pulls in all of the data and sends it over to be like this tab is the Raspberry Pi stats for that Raspberry Pi, as well as the stats for the heating and air, and that sends it to Influx database, and then that's used over here for the heating and air systems, forward and main fuel tanks, and then also it's used for the Raspberry Pi. This is just temperatures, and so like 6 hours, just the Raspberry Pi temperatures. Now this is the Raspberry Pi 4, and I've got a case on it with a cooling fan on it, so it maintains about 112 degrees. And this is the forward one, in just it's actually in the case that came with the Raspberry Pi 4. Both systems, both Raspberry Pis are running headless, but it's averaging about 130, and then we've had some peaks up around 150 or so. This one is the one that runs my, obviously by the name Media Pi. It also runs my Plex server, so my media server. There's another screen on the Node Red dashboard that it just shows the stats for the Raspberry Pi, and you can reboot the Pi from here or shut it down. And then this is just a flow that I use, a page that I use for doing test flows. I've got everything set up so like the water sensor measures every 2 minutes, it goes through this flow. Heater I think is every 20 seconds, 20 seconds it goes through. And then database, I believe that updates every 5 minutes. No, 10 seconds, sorry. Oh, this one's every 10 seconds, and then this one, sending it to Grafana, is every 10 minutes, I believe. 10 seconds? Nope. I don't know where I got 10 minutes. But that kind of sums up everything I'm doing. Let's make sure I showed you everything. I think, that's just a chart with fresh water level, heating and air. Fresh water. Tank levels. This will be kind of nice in the winter time when we're running off of our freshwater tanks solely, because I can look at this chart and watch the water level drop and know who's using what water by showers or dishes or whatever, by what time in the chart it was done. And you can look back as well. You can zoom in, or you can go out 2 days and see like this. That's when I changed the no, it's actually when we moved the boat to pump out, but you can see what it did to the sensor during that point. So I think it's going to come in handy. So alright, it was just a quick recap of what I've done so far.